All right, here's a short video for you today about greatest common factoring. So this is a binomial, two terms. We're factoring out a greatest common factor. So you scan the two terms and you look for what is in common. So I see they don't both have ends, but they both have numbers. So 2 and 4 have a greatest common factor of 2, and so I'm going to factor that out. Factoring feels like division, but you don't lose the factors. So I'm going to factor a 2 from 2n, so that'll leave an n, and I'm going to factor a 2 from -4, that will leave me a -2. So as I go to check that, 2 times n is 2n, I regain that, and 2 times -2 is -4. So I'm all set there, and that is factored. The next one includes negative signs, but it feels very similar. So you take a look at the 12 and the 3. We notice they don't both have a's, so we're going to factor out the coefficient and constant only. So 3 is the greatest common factor, and actually it's a -3 because I can take a negative from both of them, and so because they both are negative, I should factor that out. So when I put my GCF on the outside, I prepare a binomial space in my parentheses. And so what do I multiply to -3 to regain -12a? Well, it will be a positive 4a, because -3 times 4a gets me a -12a. And then what do I multiply to gain a -3? Or the other way I can think about it is, when I factor out a -3 from -3, I'm left with a positive 1. So -3 times -1, or sorry, -3 times +1 is -3. And so I factored that binomial. The last one is when you have a greatest common factor that includes coefficients and variables. And so when we take a look at this, that's my dog at the window, 12 and 16 are both even. It looks like the greatest common factor I could take out is a 2. I'd want to take out more, but one's built on 4s only and one's built on 3s and 4s, so it doesn't quite work. The greatest common factor of n is 3, that you look for the lowest number of variables that they both have in common. That's usually how that works out. So the greatest common factor is 2n cubed. So I write that factor, prepare a binomial space because I have two terms. And so when I divide or factor out from a 12, with a 2, I leave myself a 6. When I remove 3 n's out of a total of 5 n's, it leaves me n squared. So we could check that real quick. 2 times 6 is 12, n cubed times n squared. This is our exponent rules. You're actually adding those, so that becomes n to the 5th. So we're all set there. And then 16 divided by 2 is 8. Everything was positive, and I was not factoring out a negative. And then n cubed divided by n cubed actually is just 1. So if I double check that, 2n cubed times 8 should get me 16n cubed, and this is fully factored.